he's gonna keep working.
Yeah.
He says that we can translate. Start recording.
That's there.
Oh.
Good afternoon, everybody. I'm just going to mute people who have not muted themselves yet. Just a reminder, if you're going to try and speak, to unmute yourself. Okay, perfect. So we'll get started here today. So I just wanted to introduce myself. My name is Megan Skelton. I'm a part of the national accounts team here at Wolseley. I also have joining me today a few different individuals. So we have our dealer development team. I believe Jill from that team is here representing for you guys today. And we also have Craig Anderson, who is one of our lead TSAs in Ontario Atlantic. So he will be actually guiding us through the AC mechanical technical training today. Simple ground rules as some of our other presentations. If you are looking to speak, just raise your hand or use the conversation box. That's probably the best way just to communicate, and we'll answer those at the end of the training. The session is being recorded for individuals who aren't able to make the training today. And I just wanted to, again, thank you guys for joining. I know it's still an odd time, but we are still committed to offering you guys these technical training sessions. So hopefully you're finding them useful so far. I think we're on day 5 of 7 or something like that. We're getting close to the end. I think there's one more session on Thursday for the EPMS service bench and overall program support. So I'll flip it over to Craig and he'll kick us off here.
Afternoon, everybody. Thanks for coming out. So today we're going to be about 45 minutes to an hour. We've been asked to, because air conditioning season is coming up, to give a little refresher to get everybody prepared to make sure they remember what needs to be done and what tools they need in their vehicle. Like Megan said, I work for Wolseley. I help lead up the technical service program for Wolseley, Ontario, and we help out the Atlantic Canada as well when they get quite busy. So good news on our part. We have 3 full-time technical service gentlemen now, myself, Guy down in North Bay, and then Steve Martindale has signed on with us in the GTA area. So we have 3 full-time people that will be available by phone call. We're working on a 4th. So we'll have 4 full times, plus we'll still have our other TSAs that have a branch role as well. So we know at one point those guys get busy with the branch and can't get to the phone. So now that we have 3 TSAs and working on the 4th, we should be able to help out a lot quicker than normal. So like I said, today is a refresher of our AC season coming up, some technical, some stuff, some wiring, some products, stuff like that. So we'll get through it. Yes, it's a PowerPoint, so we can't be face-to-face, but this is all we can provide right now. So here we go. So I always started off gokeepright.com. If you have not been sitting in on any of the sessions, this is the go site for you guys for technical specs, installation manuals, warranty, product literature, anything you guys need to know about that unit, you can get off this go site. No password needed. Load it into your phone, laptops, iPads, computer at work, anything you need. So if you've been on the site before and you haven't been there for a while, it's been refreshed. A little nicer looking, up to date. So when you get to this website, this search box in the right-hand side will be your go-to box. This is the quickest way to get your manuals. Best way to do it is the first 4 to 5 digits of a model number, like a Furnace NXA6. That's all you need. It will bring up that installation manual. It will bring up warranty information. It will bring you the technical book, wiring diagrams, anything you need. If you call one of the people at Wolseley for technical support, this is the website they're going to. This is where they're going to go. They're going to pull up the service manual, and then they're going to start talking to you about what's going on. So great website, get it on your phone. Manuals, if there's no manual, you can print the manuals online so you have it with the equipment for next time. Great website. So we're just going to go quickly over the product lineup so you guys know what you're dealing with out there and what you're going to run into. I know some of you are owners and technicians and salesmen that are on the call, so we just briefly go up through the product lineup. So entry performance levels, we're looking at R4A3 up to an NXA6, so 13 SEER to 16 SEER. Entry level performance doesn't have the pretty cabinet. We still have the scroll compressors in them. If registered, you still have a 10-year warranty. It just has the cage look on the outside and the entry level. So when you go up to the soft sound or the deluxe, what we call it, we get into a nicer looking cabinet. Some of those units have 2-speed fan motors on it. So if it gets real hot in the area where the air conditioner on, then it will increase to a 2nd-speed fan. We can get up to 19 SEER on this unit, communicating and non-communicating. So this is your fully modulating AC. This is only fully modulating if you group it up with a modulating furnace and a modulating stat. If not grouped up in that orientation, then this unit becomes a 2-stage air conditioner. We sell a lot of them on 2-stage air conditioner because it's a very quiet unit. It's variable speed, ECM motors, all that stuff outside. But if you're going to work on one of these units or install one of these units, it best performs as a communicating unit with communicating furnace or air handler inside with the ion stat. It makes it a full 5-stage air conditioner. CCA 7, it is also a communicating air conditioner. It's a 2-stage communicating air conditioner. So it can wire in with the ion stat, or it can be wired in with just a 2-stage thermostat with a 2-stage furnace, a 2-stage capability. If it's a communicating, we only need 2 wires to the outdoor unit. So very handy if you're doing a retrofit and you want a communicating indoor unit or outdoor unit, sorry. It only needs a 2-wire to operate. CSA 6, single stage, 16 SEER unit, also communicating with an ion stat or a communicating furnace or air handler. You'll note on the warranties, all the same with the Keep Right line, 5-year out of the box, 10-year if you register it online. Whether it's going to be your customer or yourself to register it online. If it is not registered, it will not get the 10-year parts warranty. NXA6, the 16 SEER unit, down and dirty. Nice 16 SEER unit, nice and quiet. Same thing, 5 years out of the box, 10 years if we register it. So a wide variety between a 13 SEER and 16 SEER units that you have out there for looks wise and operation. This is another one on the Keep Right block, is the horizontal unit. Great unit, nice and quiet. We can get line lengths up to 250 feet on these if we're doing apartment buildings or anything like that. Also 10-year warranty if registered. The only call I really get on these units is if somebody hasn't installed them the first time. The operation is a little bit different than a standard air conditioner. It's a blow-through design. So when you actually start the unit, you're going to be thinking that the fan motor is turning backwards. The fan motor is turning backwards, but it is turning in the right direction of operation. Just be mindful if you're going to put one in there. I've had calls and been on calls with guys, installed it, been looking at it for half an hour to 45 minutes. They have no idea why that fan is turning backwards. It is designed that way. So just be mindful if you're putting one in, or if you get one of your installers that call you and say the fan motor is turning backwards. That's the way they're supposed to operate. So nice unit. Lengths, we can get up to 250 feet. N4A3, nice entry level AC. Same thing, 5-year warranty of the box, 10-year. All our units are scroll compressors, filter dryers with the unit. Just another unit out there for you to sell. Evaporator coils, wide selection of evaporator coils through Keeprite. We have the case horizontal coil. We have a case slab coil as well, case vertical coil. We have the A coils, and then we have an N coil. I don't have a photo of it right now. It's new, coming out by Keeprite. It's a V coil. It's going to come in a cabinet only. It won't be a loose coil for installation. So it's going to be in the cabinet. It's going to be a V shape. So the V shape is going to be upside down. So it's going to be typically an A coil flipped upside down in the cabinet. So this is going to help us out with airflows when we get into oil furnaces, tight ductwork. Our airflow through these coils compared to an N coil or a standard cased A coil, airflow is going to be quite greater for us to operate on. So that's coming out soon. So just keep your eyes out. And N coil, if you haven't installed one, you have to be very mindful of when installing the N coil. The N coil has two parts on it. One part where the A is, and then it has another small part where the N part is on the right-hand side. Probably a dozen calls a year or maybe more. Unit is freezing up. We have no idea why. So on the right side of this coil, we only have about 1.5 inches of gap. So if that part of that coil, if we've installed it like a typical A coil, put our channels in, 1.5 inches on each side, slide the coil in, chances are you're going to block off that right side of the coil. And if you do, the first operation of the unit, you're going to run for 15 minutes, you're going to run for 20 minutes, everything's going to look fine, you're packing up your tools, you get out of there. You're going to get a call from the customer that coil is going to freeze. We're not getting any airflow through that right side. So when you grab that coil and you take it out of the box, it's going to have a metal frame on the bottom of it. You can take that metal frame off, and this is your template. So there's two ways to install it. You can flip it upside down to what it looks like right now and set the coil on top of it. Or you can keep it up the way it is, where you took it out of the coil, mount that template in the plenum. As long as you're making sure that whole opening of that template is wide open, then you're 100%. So when you set that coil back in, you know, before you put a patch on it, that coil is going to be 100% open. If you put rails in and you slide that over top, chances are you're going to block off that right-hand side. Been to a lot of job sites, traveled a lot of miles just to confirm that the coil has been blocked off on the right side. So if that's something you're running into on a coil or an existing unit that's out there, then that's something you need to look at. You need to get in there and look at that coil to see how it's mounted. So required tools, we need to go through this. We want to make sure that you have the proper tools that are in the truck, what we need to have in the truck to do the job properly. So my whole gauges, sets, let's not mix match them. If you're working with R22 and you're working with 410A, have two sets of gauges. The oils don't mix properly, and the different refrigerants, they actually eat away at each other. So keep your gauges away from mixing Freon. Make sure your gauges are calibrated. Make sure your O-rings are good. They've been sitting for a while now. You haven't been using them. Get them out, take a look at them. There is O-ring kits to replace them, or just replace your hoses. Make sure everything's working fine. If your gauges aren't good, it can, when you're doing a vacuum, you could think that you have a leak in the system, and it's actually your gauges leaking and you're not pulling a proper vacuum. So make sure your gauges are good and well maintained. Cutting tools, flaring or deburring tools, you don't think it is a big thing, but it does come down to a big thing when we're talking about flaring. A lot of our units now are mini splits, stuff like that are coming with flared fittings. So we need to make sure that we have a proper flare. If we're not deburring the copper, then when we're doing our flare, some of the flaring tools will actually make a double flare on the top, and you're not going to get a proper seal. Let's deburr it. Let's make sure when we're deburring it, the filings from the deburring tool are not falling in your copper. Always point your copper down. Make sure those filings are falling out. Our TX valves, our EE valves, reversing valves, these all have screens in them. So if we're getting any particles in the system that are blocking off these screens, then it could affect the operation of our air conditioner, especially when we're in a mini split situation. We're dealing with 1/4-inch copper, 3/8 copper. It doesn't take much to block that. So make sure we're deburring it. We're not getting the filings inside the copper, and we have everything proper for cutting tools and stuff. Vacuum pumps, big thing also. Make sure your vacuum pump has been serviced. I know some of the branches actually do vacuum pump days. It's great. You bring it in, they change the oil for you. Minimum 6 CFMs. Let's not get too big on a vacuum pump on a system. We can create problems that way if we're pulling the vacuum down too quick. If we're pulling a vacuum down too quick, we could actually make the inside of the copper freeze with the moisture that's in there because we're drying it down too quick. Once you draw it down, you turn it on, then that frozen moisture unfreezes and we get contamination in our gauges. So mindful, nice low vacuums, 600 CFMs or 6 CFMs, sorry. Let's make sure we have a built-in check valve in our vacuum pump in case that vacuum pump turns off when we're doing a vacuum. Your system's going to be in a negative pressure. So if your vacuum doesn't have a check valve and it turns off, we can actually pull in liquids from that vacuum pump into our system. So we want to make sure that we have a built-in check valve and the vacuum pump is operating properly. Oil changes, frequent oil changes. I'm not saying to pull a vacuum after, change the oil after every vacuum, but we need to constantly change the oil in that vacuum pump. That oil is what is taking in the moisture. So if you're doing a lot of jobs, you'll notice your 10th or 12th job, why is it taking so long to pull this vacuum? Do I have a leak? Maybe your oil is full of moisture now. It can't take any more moisture in. New systems aren't too bad, but when we're doing a retrofit, when we're doing something that's already had Freon through the system and has been open, there's a lot more moisture, especially if we're vacuuming the outdoor unit. So those units are going to take a lot longer to vacuum. So if you've got clean oil, then that's going to help you get your vacuum a little quicker. So maintain your oil. Flaring tools, big thing. You can buy flaring tools out there that are not 45 degree, R410 rated. If you're doing a lot of flaring, make sure you have the proper flaring tools. You can get them at Canadian Tire and Princess Auto and stuff like that are not rated for a 45 degree flare. Our refrigeration on our mini splits and stuff like that take a 45 degree flare. So if you running into a lot of leaks on mini splits and stuff like that, check your flaring tool, make sure it's proper, and you're using it properly. Digital vacuum gauge. If you guys do not have one of these in your truck, you need to get one of these in your truck. This is the only way to properly check to see if you have a proper vacuum. We need to pull it under 500 microns. Looking at your gauge, timing it for 15 or 20 minutes is not going to tell you if you have the proper vacuum on that unit. So digital vacuum gauge, if you don't have one, you need to get one, whether you're installing or if you're doing service. If you're doing service, chances are you're going to be pulling a vacuum at some point on an air conditioning system. You need a digital vacuum gauge. Scales as well. Every service guy, every installation guy needs a scale in their truck. They do not have a scale in their truck. They are not properly charging a system. Most systems, and read the manual, everyone is a little different. Some are charged for 15 feet of line set, some are charged for 25 feet of line set. If it's over that length of line set that it's charged for, we need to add gas. The only proper way to add it is to weigh it in. If you're not weighing it in, you're not doing it proper. If you weigh the gas in, you're taking that out of the equation, out of the loop of what is going on with this system. We know we've weighed it in. We know we have the proper amount of gas. Let's work on the next step. Let's check airflow. Let's check filters, stuff like that. Modulating compressors, mini splits, the higher end 5-stage air conditioner, you can't check pressures with your gauges because we have no idea what stage the compressor's in or the EE valve that's monitoring the refrigeration going into the system. Your gauges aren't telling you because we have no idea what stage that unit is. So really we have no idea what pressures we should be reading at that point. So it only way to do it properly is to weigh the gas in. If you talk to a service guy on the phone and you're telling him, I added some gas, I took some gas out, he's going to tell you to take it out and weigh it in. So save the headaches, take it out, weigh it in, you know that's proper, and let's move on. When we get into the modulating air conditioners and stuff like that, the only thing your gauges are telling you at that point is the compressor's running. We have gas in it and the compressor's running. That's all we can really check. So make sure you got a scale in your truck. It's the only way to do it properly. Couple other things out there, little nitrogen purging tool, great little tool. There's no setup on your nitrogen tank. You put it through this little thing and it monitors the amount of nitrogen going through your system so you can do a proper weld. We want nitrogen going through the system. It keeps the pipes clean. If we're not cleaning the pipes, then we're getting flaking of the inside of the copper, and that's going into our screens and the meshes that are on the EE valves and stuff like that and blocking them off. So make sure you got a nice little purging tool. There's nothing to set up. You turn it to purge. It monitors the amount of gas that's going through your line. So great little tool for when you're welding. Other installation tools, pipe benders, spring benders, Allen keys. We have the little Ritchie service wrench over here that's great for our service valves. When you're working on your service valve, always open it up with a standard Allen key first, then go to your ratchet wrench. Not all the valves will allow that ratchet wrench to fully get into the service valve, and you're going to cause stripping. We've just heated this service valve, and then now that these wrenches are not, and I'm not going to say everyone, but some of them, you will not get deep enough and you're going to strip that service valve. So it's not fun to change it. So always start it off with a standard Allen wrench and then go to your ratchet service wrench. You're going to save some headaches. If it's never happened to you before, that is great. But when it does happen, it ain't pretty on a brand new unit when you're outside. Other tools, manometers. You're going to need these, whether it's in heating or cooling. We need to start checking static pressure more frequently because we're dealing with ECM motors. Pocket thermometers, Always have two, so you can check your return and your supply at the same time. You're not bouncing back and forth. It's going to cut a lot of time off if you have two. A nice multimeter clamp on so we can check amperage. Refrigerant leak detector. Not everybody needs one in their truck. It's great to have one in the company if you have one of those leaks that are hard to find. Digital cyclometer. Do your wet bulb, dry bulb in the house. Great little tool. They're pocket tight now too as well. Digital vacuum gauge scale. Like I said, we need these in all trucks. Properly do the job, we need a digital vacuum gauge and we need a digital scale. For the real techie guys, top left corner, that's called a Hub 6. So what this is, has two clamp-ons for your outdoor pipe, your suction and liquid line. You can check the temperature. These are your gauges now, the two center things, they screw on outside. And then we have two temperature probes go into our return and supply. This is all via Bluetooth. So this is fantastic. You can do air adjustments inside without being outside, looking at your phone or your laptop or whatever device you have. And once you change the airflow, you're going to be able to check to see what that outdoor unit is doing. So if you're out there and you're thinking about getting the new digital gauges that are going to tell you superheat, subcool, and all that, great little piece of equipment to take a peek at if that's something that you're in the ballpark for. It tells you everything, your subcooling, your superheat, temperatures, great little machine. Good piping practices, standard. A lot of guys do new home construction. They go, they throw the lines in, then somebody's going to go back and put the air conditioner in. Start crimping the pipes, soldering them outside, quit taping them, putting caps on it. Don't know how many job sites you've been to where the guys have parged it and there's cement all sticking on the outside of the copper because we taped it and it's fallen off. We have no idea what's gone in through that copper line now. We have it hooked up to our coil inside, so blowing it out is out of the question. If we blow nitrogen through it, then we don't know where we're putting that dirt on. So start crimping the lines outside. I'm not saying braze them, at least as we're crimping them, we're taking that part of the equation that our lines are clean when we go back. With all this modulating stuff, we don't want anything floating around in there. It could just cause havoc for the service guy that's going back. So good practices as well when we're welding, like we talked about, we're blowing dry nitrogen through the lines. So we're keeping the inside of the copper clean so we're not getting any slag moving around the inside of it. We're taking the valve cores out. We don't want to overheat them. There's rubber in them, on them. We don't want to overheat our valves outside either. So we're going to put wet cloth around it. Or the stuff here that's in the picture is called heat block. It's about $35. And it should last you about a year. It's reusable. As long as you keep it moist, it will stop any heat going into that service valve. You just take it out of the container, you wrap it around your service valves. Much better than a cold cloth. There's demonstrations, people put it on a copper pipe and hold the other end while they heat the other part red hot, and it doesn't get hot on the other side. So great stuff to have in your truck, especially if you're working on coils inside too. You know, the little stub that comes out of that plenum isn't very big. Wrap this stuff around as tight as you can. It's going to stop the heat from going into that TX valve. We get a lot of burnt out TX valves coming back. We start dealing with 7/8 and 3/4 inch copper. It's being overheated and ruining the TX valve. So if you don't have this stuff in your truck, get a container. Like I said, it's going to last you all year. Good flaring tools like we talked about before. When we're doing our flare, make sure we got good cutters. We got deburring tools, a good set of flaring tools. Let's make sure we got a good flare. If you're going back to get a bigger wrench, then that's not the problem. There's something going on with your flare, something going on with your flare nut. So make sure that you have a good flare and you're ready to go. So when we're doing our flare, sometimes your nut is a little tight. Just take some synthetic oil, put it on your copper pipe, help free up your flare nut. So when you're putting it on, you're not jamming or you're cross threading. Try not to get it on the threads because we don't want any oil on the threads. We want it to be brass to brass. Once that brass to brass is connected and we have a good flare, chances are you're not going to have a leak. But you need the right flaring tool, 45-degree flare. If you have torque wrenches, let's get the torque wrenches out. In the manual tells you what that nut should be torqued down to. Like I said, if you're going to get a bigger wrench, that's not fixing the leak. It might be causing more of a leak. We're going to mushroom the flare. We're just going to cause problems. Still make sure you're back wrenching it as well. We don't want the copper twisting. Like I said, 1/4 inch 3H copper. Not a lot of room for Freon to flow through there. So if we're kinking the line or twisting the line, we can cause the flow of the Freon going into our DX valves and stuff. Pressure checking, another big thing out there. We call it the 3-step. All the 3-step is doing, it is saving you nitrogen. Let's not put 600 pounds in it and see if we got a leak. If you got a leak, you just lost that 600 pounds. Started off with 100 PSI for about 5 minutes. If it doesn't move, bump it up to 300. Doesn't move, bump it up again. This way here, if we do have a leak, you're not losing as much nitrogen. It's not doing anything else but saving you some nitrogen down the road. Let's increase it up to 600 PSI, 500, 600 PSI. Let's get it up there. We can get up to those pressures on a 410A system if that unit is out in the heat and it's the coil's blocked outside. We can get high pressures on that before that compressor is going to kick off. Compressors usually kick off just over the 500 mark. So let's make sure we do our nitrogen check. And once that compressor turns off, the discharge valve will go. So let's make sure that we're nitrogen checking at a high PSI. So we know that our leaks, we have no leaks. And let's check it for an hour. So testing for leaks, a lot of guys will throw nitrogen in if we have a leak somewhere in the system. There's special soap out there for refrigeration systems. It's designed for refrigeration system. It's not going to affect the oils that are in the Freon. Using dish soap, household cleaners, stuff like that. We don't know what kind of effect, if it gets in the system, what it's going to do to the oils in the system. So buy the right stuff. It's usually in one of the branches. It's made for refrigeration. So when we're checking leaks. Standard AC units, they're allowing leak dye to go into the system and refrigerant leak seal. We've been told by Yellow Jacket Ritchie that tools that they've seen out there is really that come back, vacuum pumps, gauges, stuff like that. This stuff is not really affecting any of the tools that are out there. The only time we don't want the dye and the refrigerant seal leaking is when we start dealing with ductless splits, because the strainers and the small diameter of piping that we're dealing with, we don't want any of that stuff into a ductless split system. Leak lock as well onto the flare fittings. If you got a leak, don't put leak lock on it. We don't want anything that's going to get in the system on these ductless splits. If a unit comes back and it has leak lock all over it, you will not get warranty for that unit. It will be rejected. So vacuum, that's a big one. We were talking about that before. Let's start off the beginning of the season. If your vacuum pumps have been sitting in your truck and not using them, get them in the shop, change the oil, check all your seals on it. We want to make sure we got a proper evacuation. If we don't, we're going to get contamination in the system. We're going to get moisture in the system, and it's just going to cause havoc on the compressor later on down the road, or it's going to cause havoc all year round on that air conditioner. So let's do a proper evacuation. It's a triple evacuation procedure, it's called. It's been in the manual for years. This is not something new. Let's turn the vacuum on. Let's get it under 4,000 microns. Let's hold it for 15 minutes. If it doesn't hold, then we know we got a big leak, especially at 4,000 microns. Let's throw some dry nitrogen through it. We're drying the line out a little bit more. Turn it back on, bring it down to 1,500 microns. Same thing, hold it for 15 minutes, blow it out with dry nitrogen again, dry the line out again, some more. Let's turn it back on. Let's bring it under the 500 microns. When we're talking about bringing it under the 500 microns, we want to bring it under the 500 microns and we want to hold it there. Not bring it to 500 micron, turn your gauges off, turn everything off and crack the lines and let's go. Let's isolate your gauges, isolate the vacuum. Let's hold it under 500 microns. So when you turn that vacuum pump off, chances are if it's a new system, you're going to be reading about 78 microns because it's going to pull it down to that. And then once you turn it off, that micron gauge is going to climb. We're looking at that micron gauge and we need to make sure that it stops and doesn't go over the 500. If it goes over the 500, then chances are we still have moisture in the line or we have a leak in the line. You want to keep it under 500 and it needs to hold under 500. Once we know it's held, let's go to the next step. If it needs to add gas, let's add the gas while it's under a vacuum. Put the new gas in it and then track the lines outside. If you're adding the gas before you're cracking the outdoor unit, because some of these systems are have low pressure switches on it. So if you got an 80-foot line set or anything like that, if you don't add the gas, so if you're about 80 feet or 50 feet or whatever, you're probably going to add a pound or two of gas to the unit depending on your system. If you don't add that when the unit is under a vacuum, then chances are when you crack the outdoor unit and throw the charge from the outdoor unit, there's not going to be enough gas in that unit to make your low pressure switch function. So now you're going to have to get into jumping low pressure switches and stuff like that to get it to turn on so you can add your gas to the unit. So always add your gas while the unit is in a vacuum. It's a little bit easier. So a little bit of AC troubleshooting. This is a contactor. I'm sure you've all seen one before. I get a call every year on this. I don't have 220 volts outside, or I do have 220 volts outside and my air conditioner won't turn on. My contactor is pulled in. So when we're checking 220 volts, we're going from L1 to L2. We're not going from L1 to ground or L2 to ground. There are panels out there that allows you to put a breaker in that only allows you to take it from one leg of the panel. So when you go outside and you're grounding going to L1, it's going to tell you that you got 110. L2 to ground is going to tell you that you have 110. But when you go across L1 to L2, it's going to read 0. That means you don't have 220 volts out there. You have 110 on each side. And if you throw a screwdriver on there, chances are you're going to get a zap, but you do not have the full capacity of the 220 because we're only bringing it off one leg. So be mindful if you're installing or you're teaching one of the guys out there that he knows properly how to check the 220 out there. I do get calls on it every year. Other side of the contactor is our 24 volts from our indoor unit to outdoor unit. That's going to close our contactor to make everything work. Capacitors, another big thing. They're in every air conditioner. We have a compressor, we have a fan, and the capacitor is there to help boost each piece of equipment to start. So if your amp probes or whatever you're using doesn't have the function of testing a capacitor, then you need to get a capacitor tester, or you need to upgrade your amp probes. We get tons of these back every year. And when I used to work at the counter, we sold a bunch of them, and I used to test some of them. People would come in and they would just grab one because they thought that was a problem. The fan didn't come on, but they never tested it. Takes 5 minutes, test it, make sure you got the right microfarrads, and move on to the next step. So testing, using your testers, the proper equipment, the proper tools helps tremendously when you're out there doing some troubleshooting. Compressor, everything's running, contactor is pulled in, fan is running. I have 220 going to my compressor, but nothing is operating. So first thing we're going to check for burnt wires on either end. Wires looks good. Now we're going to check the resistance in our compressor. So when we're checking our resistance, we can check them on the wires going to the compressor, or we can check them right on the compressor. Proper reading is right on the compressor. That way we're eliminating a wiring harness or anything like that. So if we're checking from R to C, we're going to get a reading. And when we check S to C, we're going to get a reading. So those two readings added together should equal your R to S. If they don't equal, then we're looking at something's going on with the windings in our compressor. If we're going to R to C or S to C and we're getting an OL or something weird, or one of the windings is like 0.08, the other one's 8.3, you know you got some windings that are in error. But those two should equal up when you add them together to your R and S. Another thing to check as well is that compressor warm. If that you can't put your hand on that compressor, chances are the internal overload is open. So if you go from R to C and go to S to C, are open circuits, and your R to S has some resistance on it, then we know we have an internal overload that's open on the compressor. So you have two options at this point. Get some water and try to cool down that compressor. So to see if we can get that overload to close again, or you're going to tell the customer that I'll be back tomorrow. This unit needs to cool down. If once it's cooled down, if the overload is still open, then we're looking at changing a compressor. So another thing to have in your trucks, if you don't have it in your trucks, put it in your trucks. AC season starting, you're going to get out there, people are going to turn their air conditioners on. Compressors aren't going to start. They've been sitting all year, especially on the older ones. This is the booster kit. Hook it onto the existing capacitor that's there. This will give our compressor a little get up and go. If that doesn't work, then we're probably looking at a point of changing the compressor out or the unit. But this little device for the price of them, $35 or whatever they are in that range, could save a customer another couple years on their air conditioner. Or that unit just needs a little bit to get up and go. Real long line lengths, 50, 80 feet, stuff like that. Good idea to have one of these compressors working. It's working hard. Throw one of these on. Get you out of a good jam. I know when you get busy, you're doing 10 to 12 calls a day. So this could save you a lot of time for a customer. Just get that compressor going and get off to the next one. 24 volt wiring. Now we're testing our unit to make sure it comes on. So if we're dealing with a two-stage air conditioner, we're going to have a Y1, Y2 outside, which is our staging for our compressor outside. Some units will have a R terminal. So when that air conditioner turns on, we should have 24 volts on R, and then we should have 24 volts on Y1, Y2, depending what stage it's on. Always go from your common to whatever you're testing on your 24 volt side. Heat pump application. the heat pump is now an air conditioner. So there's other things that you need to look at. You need to look at your O terminal. Your O terminal is going to be energized, which is your versing valve. You're going to need to make sure that you have 24 volts on O. You're going to need 24 volts on your R, Y1, Y2 as well. So these are things that you need to look at, especially when you're on a heat pump. A little bit more going on there. We need to energize that that reversing valve as well. Typical 24 volt wiring for communicating stat. 4 wires upstairs, 4 wires to the indoor unit. Whether it's an ion or if it's an observer stat. 24 volt wiring for, we have a communicating indoor unit, communicating stat. Customer has a standard AC outside. We can hook it up. We just need to tell that communicating stat we have an AC on it. If you're going to install an AC on an existing communicating system, once you install that AC, you're going to have to go upstairs to that stat and tell that stat to relearn. It's going to have to learn that it has an air conditioner on it. If you don't, then the air conditioner at any point will never turn on until you tell that stat what to do. Same thing if they have a 2-stage or heat pump system outside. We can hook it onto a communicating system via another relay that we have to hook up downstairs. So we put another relay box downstairs, hook it onto the existing communicating furnace, and then we can go outside to our 2-stage AC or heat pump. Same thing, have to go upstairs and we need to tell that unit that we've added something to it. Air handlers, not too bad. We don't have to add anything extra on it because an air handler is equipped with a computer board that's standard for heat pump application. Usually if we're doing an air handler, we have backup electric heat and we're putting a heat pump on it. That's standard application for an air handler. So the computer board on that will take a non-communicating heat pump and stuff. Another thing with the communicating system, if you're into a big house and the customer's complaining about air distribution, it's cold over here, it's warm over here. If they have the communicating ion system, they have the opportunity to add sensors on that system. So we can add up to 4 sensors. And what you could do is place the 4 sensors around the living area, and it will take the average of those 4 sensors to heat and cool that spot. Great for small commercial buildings as well. With a couple sensors around that small commercial building, heat and cool the place. Might keep some people happy. So just if you're into communicating systems, you have that opportunity to do some remote sensors. So system evaluation. This is our final documentation. You've done your nitrogen tests, you've done your vacuum, we have our low voltage, our coils in properly, we're ready to go, we're ready to turn this air conditioner on. If you don't have a startup sheet, start filling one out. They're available online. We want to document static pressure, our low side or high side gauges, electrical going to the unit. We want to know what's going on with that unit. So if somebody else goes back, you've done your due diligence, you know you've done your job right. I've checked it out. This air conditioner is running 100%. Something else has happened. So you can leave it with the customer so they have it. Take a picture with your phone so you have a copy as well. So everybody knows that, hey, I've done it. It's working. Let's move on. So we're going to consider all the readings before making a final diagnostic on the unit if it's running properly or not. We want to record all the readings. This is just covering our butt, and it's great for the next guy that's coming in or you going back 2 years later saying, okay, this is what I had when it first started. Let's see what it has now. So when you're looking at it, refrigeration system is an evaporator, coil, compressor, condenser, metering device, whether it's a piston or a TX valve, we need to be mindful of what we're working with, whether it's indoor coil, outdoor unit, what is equipped with. Static pressures. If you're not checking your static pressures, start checking your static pressures. We're dealing with the ECM blower motors. They're looking to operate within a certain static pressure. If they're not, they're going to overheat and they're going to shut off. They're going to give you nuisance high limit calls. They're going to give you nuisance freezing of this unit. You're going to get there, that motor's going to turn on, everything's going to be hunky-dory. You think, if you haven't checked that static pressure. Typical static pressure for a system is 0.5 to 0.8. This is the range we like. If we're too high, then our motor is working too hard. And then we can be looking at failed motors on a unit on a yearly basis or something to look at. So if the motor is overheating and slowing down, we can get improper airflow going through that coil and we can get freezing. If we don't have any static on the motor, then what happens is the motor is looking for something. It's always searching because it's trying to hit a static pressure. So it could be revving up, slowing down, revving up, slowing down. So static pressure is a big thing. There's a lot of YouTube videos out there. They're only about 5 to 7 minutes long, showing you how to do the static pressure, testing your coil, testing your filter. It's a fantastic little thing just to look at once a year or twice a year, keep yourself refreshed. But static pressure is a big thing. Dirty filters. We're not too bad with the 4 to 5 inch standard pleated filters. If you can upgrade the customer to that, these 1 inch 3M filters that they're buying at the stores are like cardboard. High limit issues all year. I've seen high limits range 15 to 30 degrees. Buy a filter. That's a brand new filter out of the package, doing that much of a temperature difference in our plenum. So be mindful of what kind of filter they have. Buy a box of the cheap disposable ones, keep them in your truck. Trust me, you're going to go through them. Everybody is buying these filters at Costco and Home Depot and Canadian Tire, and we've been pulling them out all year long. So it's going to run into air conditioning season as well. So static pressure, big thing, record it. Temperature rise, just like if we're starting up a gas furnace, we're looking at temperature rise in our air conditioner. We're looking for the TD between the return and the supply. Let's make sure we're in the parameters of what it's asking for on that unit, that SEER level. So this is why we need some pocket thermometers. I always say 2, so you're not taking from your supply, taking your return, waiting for it to cool down to get the temperature and moving it back and forth. 2 pocket ones, throw them in. Let's sit there and see what it's doing. So static, temperature rise, another big thing in our air conditioning systems and our heating. So next you need to know what kind of coil we're dealing with or what kind of outdoor unit we're dealing with. So we have fixed metering devices, which is our piston. So we could have a piston coil or a TXV coil. We need to be mindful of our outdoor unit as well if we're working on a heat pump. Some heat pumps have TX valves outside. Some heat pumps are metered outside with a piston. So you need to be mindful of what metering device we're using in the indoor or the outdoor unit, because this is going to tell us if we're going to use superheat or subcooling to do our tests and how the unit's operating. So metering device, refrigerant flow control. It's bringing our Freon to our coil and monitoring it going through the coil. Meters refrigerant into the evaporator coil. Creates the pressure drop needed to lower the saturation temperature, boiling point of the refrigerant. That's what our metering device is doing in our coil. 2 basic types, fixed, which is our piston, adjustable, which is our TX valve. So the TX valve has the ability to respond to change in the load, can maintain a proper superheat level by adjusting to the changes in the suction temperature and the suction line temperature. So if you notice in the picture, we have our TX valve and then we have a probe that's on our suction line. So it is monitoring the temperature of that suction line and telling the TX to open or close. Where a standard piston is, this is what you're getting all the time, doesn't matter. Where our TX is going to actually try to monitor and keep that flow steady. So connecting our manifolds to our outside, our blue hose is going to our suction line, which is our larger pieces of copper. Our yellow one is going to our vacuum pump, or it's going to our charging cylinder, where our charging cylinder is sitting on our scale, because that's the only way we charge it, correct? Red hose is going to our liquid line service valve. So we're ready to go. So typical thermometer location. So the best ones are the clamp-on thermometers. You can buy the accessory to go into your meter, or you can actually buy a kit that has just clamp-on thermometers. Clamp-on thermometers, we're getting the whole surface of the copper, and it's getting us a better reading. If you don't have clamp-on thermometers, we're going back again. We need some pocket thermometers then. So you want to take this pocket thermometer, you want to get it in, so because you want to be able to see the temperature of your suction line and your liquid line while the unit is running. So charging a fixed mixing device system, superheat while you're checking. So your piston, we're doing it with superheat. We're checking the saturation temperature. We're also going to check our subcool too. We got our thermometers out there. We're going to check our heat, superheat, and subcooling. Doesn't matter if it's a TX or a piston. But if we're doing a piston, subcooling is our temperature that we're going to use. Indoor temperature drop, which we call our split. So that's our temperature between our return and supply. Charging a TXV, we're still going to check our subcooling. So we're going to check our condensing saturation temperature, our superheat, and our indoor split between our return air and our supply. So identify the evaporator temperature sensor. Determine the refrigerant type that you're using and your saturation temperature. So when you're looking at your gauges, your pressure is going to be on your outside of your gauges, and depending on what freon that you're working on is going to tell us your saturation temperature. So we're going to need that temperature, plus we're going to need the temperature that we've got off our suction pipe outside with our electronic thermostat. So saturation temperature, suction temperature. So once we have these, we have our suction line temperature and we have our evaporator saturation temperature that's found on our low side of our gauges. Once we have that, we minus it. That's going to tell us our superheat. Pretty simple. Measure the temperature of your pipe outside, find your saturation temperature on your low side gauges. That's going to tell us our superheat. TX systems. So TX systems are designed to regulate a constant superheat like we talked about. It's going to move up and down. It's going to try to keep the required superheat and keep it constant. So typical superheat is between 10 to 12 degrees. Check out your unit. Some of the higher units are a little bit different, but this is a typical reading that you're going to get on for a TX system. So fixed metering device systems, we always have a tolerance. Doesn't matter what we're dealing with. If we're dealing with electrical or freon, we always have that plus or minus tolerance. We always want to go to the plus side and not so much to a minus side. So same thing with refrigeration and our readings. We always have that little bit of a tolerance that we can play with. So determining required subcooling. The unit's going to tell you typical subcooling, condenser SEER rating, sometimes depends on what kind of subcooling. So refer to your chart, whether it's in your book or it's on the side panel of the air conditioner or the heat pump that's out there. Subcooling is only a checkpoint for a fixed metering device system. TXV systems, it's the primary charge when we're doing a TX subcooling. Same thing. Now we're looking at our high side gauge, our red gauge. So we're on the small line, the 3/8 line, the high side. So same application. We're going to check the readings. We're going to see what that high side's doing. And we're going to check the temperature of that high side copper that's going through. Same application we did with the suction line. We're doing it with the other line. Condensing saturation temperature minus your liquid line temperature is going to give us our operating subcool. So we're checking both. We want to make sure both are in the right parameters, whether it's our subcooling or our superheat. We need to make sure we know if we have a piston inside or a TX valve inside. Same thing outside. It can determine what kind of readings that we're looking for when we're doing this calculations. And that's bang right on time for you today, guys. I hope you got a little bit out of this. We're getting in air conditioning season. We just wanted to refresh everybody's memory. This is all we have. Like I say, it's always better if we're in a little room and we can touch and feel and test things and stuff like that. This is all we got for now. So hopefully you did get something out of it today, and we can move on to the hot weather and get our air conditioners going.
Thank you very much, Craig. I'll invite you guys to ask any questions you have in the chat at this point, and there are two right now pending. So the first one is for dead on arrival air conditioner. Can you advise on what to do and what steps need to be taken for smooth processing within Wolseley and the TSA group? Does a compressor document need to be filled in and submitted with the unit, etc.?
So yes, so if we have a DOA compressor or unit that is not operating, for in normal business hours, yes, we'd like you to reach out to one of the TSAs. We need documentation to go back to ICP or Keep Right or our TSAs. So us as TSAs, we have TSAs that we have to go to. So any documentation that we have, there's operating sheets that we need to fill out. Do we have the right power going outside? Is our capacitor good? Stuff like that. So yes, there is a procedure. More information we get, the better. And the process is smooth. The dropping off an air conditioner to a branch the next day saying it doesn't run, I want a good one, that just creates a lot of havoc for the branch and the TSAs. So yes, like I said, startup documentation is 100% amperage, pressures, anything you can give us gives us a better, smoother go through. But if you can talk to a TSA, that is the best way to start.
Thanks, Craig. The second question. So in the case where communicating stat is required, but the technician can't use shielded wire due to a finished ceiling, what are the is there any other options they can use?
So a couple tricks. If we're doing communication, you don't need shielded wire. We have run into applications where the thermostat wire has run through computer rooms or taped to the high voltage for 80 feet down the line. where we've run around some communication issues. Not a big concern unless those little applications are going. A couple tricks that seem to help the problem, if we couldn't get in there and put shielded wire or change the wire, if we had an extra wire, if they ran a 5-wire, because we only really need a 4-wire. I've had applications where if we had that extra wire, we grounded that wire to the furnace downstairs to the grounding, and it actually took some of the harmonics away, and we didn't have as many communication errors. It actually cut it down by like 75%, where we were getting 3 or 4 a year, where they were only actually getting 1 a year. So little steps that you could try. But if we can run a new wire, then we do. But shield is really not necessary unless you're in the application where we're running along high voltage or a lot of high voltage, or in computer rooms where there's a lot of computer frequencies and stuff going on.
Well, perfect. Thank you, Craig. If there's any other questions, I'll let you guys put those in the chat. If not, thank you guys for joining today. Hopefully, like Craig mentioned, that this was at least you learned something or took something away from this. For the Climate Care group on the call, our next set of calls is on Thursday, 8 a.m. and 1 p.m. for the EPMS. Go Keep Right. We're going to be going through the dealer portal and also any service bench support that you require. So that will be our final session, and we'll see you all there. Have a great day.
Thanks, Megan. Thanks, Craig.
Thanks, everybody.
Thanks, guys.
Thanks, Megan and Craig.
Everybody have a good day.
Bye-bye.